Okay, we're getting somewhere with powers. We're getting somewhere with powers. I'm going to I'm going to say some. I'm going to do something else. I'm going to talk about how to raise powers of 4 times 5, and I want to cube that. Let's just try it. 4 times 5 cubed. Well, I can just say that's 20 cubed, and I can say that's 20 times 20 times 20, which equals 8. And how many zeros? 8,000. Well, alright, so that's what it is in numbers. Let me just write it out in a slightly different way. 4 times 5 times 4 times 5 times 4 times 5. There you go. So let's have a look at that. Well, what we've got there, we've got 4 times 4 times 4, because we've got that 4, and that 4. Put it in brackets because I feel like it. Times 5 times 5 times 5. 5 times 5 times 5. Sweet. So what that's telling me is that 4 times 5 cubed equals 4 cubed times 5 cubed. Yeah. And this allows us to simplify a lot of expressions. Let's try, instead of 4 and 5, well, no, let me stick with 4 and 5. 4 times 5 to the power a equals 4 to the power a times 5 to the power of a. Okay? And although I'm not going to prove it, this is true for any a, because I don't just need a cube. I could put any power there. I could put 4th power or 9th power or 125th power. So I'll just write 4 times 5 to the power a. And of course there's nothing special about 4 and 5. So I'm just going to write x and y to the power a equals x to the power a times y to the power a. And I'm going to assert, I'm not going to prove, I'm going to assert that this works for any a. So let's just have a look at that and see what it says. I'm going to put a equals, well, let's try 0, so I guess it's the easiest. X, so what we're saying is that xy equals 0 equals x to the 0 times y to the 0. So what that's saying, we know that anything to the power 0 equals 1. So what this is saying is that 1 equals 1 times 1. Well, it does, of course it does. So that checks out. That's supposed to be a tick. A equals 1. Xy to the power 1 equals x to the 1 times y to the 1. Well, that's just saying that xy equals x times y. Well, of course it is. So there's nothing clever there. And we know that it works for any larger number. Let's try something a little bit more interesting. Let's try a equals 1/2. So what that's telling me now is that xy to the power half equals x to the power half times y to the power half, or the square root of xy equals the square root of x times the square root of y. Now that's a bit more interesting, and I'm going to try that with x equals 4 and y equals 5 just for the hell of it. So what I'm saying is that the square root of 4 times 5, which is of course the square root of 20, equals the square root of 4 times the square root of 5, which equals, square root of 4 is of course 2 root 5. So what we're saying is that square root of 20 equals 2 root 5. Let's just verify that with the old Microsoft calculator. 20 square root, there it is, 4.472 approximately, 4.472 versus, and I'll do the other one, 2 times root 5. 5 square root and then times 2. Where's times? Oh, it's there. Times 2 equals 4.472. So it seems to check it out. It seems to check out. So that's just a nice way of thinking about square roots. Okay, I'm going to stop there.